video, we are going to check some calculations on mole concept. So we will be discussing on doing some calculations on mole concept. So let's get started. Mole concept. So first of all, what is mole? So mole is defined when we have, let's say, when we have some chemical units that is equal to the number of 6.022 into 10 to the power 23 by amount, that is now called as 1 mole. For example, normally we know when we have something by amounts 2, let's say when we have 2, we do say it's as a pair. So if I say a pair of cups, so what do we mean by that? We have 2 cups, yeah? We have 2 cups. Or else if I say a dozen of books, what do I mean by that is a dozen refers 12. Similar, like when I say mole, it refers this many number, which is also called as Avogadro constant. So if there are 6.022 into 10 to the power 23 chemical units, those chemical units can be atoms, molecules, anything. They are called as 1 mole. So the mole is a convenient unit to use. It's because every time when we have this many chemical units, we can't keep on seeing it as 6.022 into 10 to the power 23. Rather than telling this, saying 1 mole of this particular compound is easier. So this is a convenient way to be used. All right. And the unit of mole is mol. That is, if I have 1 mole, I will be writing it as 1 mole. All right. Monomers. So in mole concept, we have another important topic called monomers, and let's have a look at monomers. It is defined as the mass in grams of 1 mole of a substance. For an example, when we do study about speed, we know the unit given is kilometer per hour. Likewise, so this tells us how many kilometers we do travel within 1 hour. Likewise, monomers is how many grams do we have of a particular substance in 1 mole. So, for an example, if we are measuring 20 grams of sodium, how many moles are there in this 20 grams? This is known as monomers. Now, how to calculate the monomers, which is the important part. So we should be able to calculate the monomers if the compounds are given. And for that, yes, we have to use the mass numbers. For an example, the mass number of sodium is 23, oxygen is 16, hydrogen 1, chlorine 35.5, carbon 12. So using these mass numbers, we can find the monomers. And where do we find these mass numbers? These mass numbers will be provided in the periodic table along with your examination paper. So you can find out the mass numbers there in the periodic table. Now let's get started and let's try calculating the monomers of the following substances given. So I said for sodium, it's 23. So initially I will have right 23 plus. Now for oxygen, it's 16, and for hydrogen, it's 1. Adding up this gives me 23, 39, 40 gram per mole. What do I mean by that is, when I am measuring 1 mole of NaOH, that is sodium hydroxide, I will have 40 gram in it. Or else, if we have 40 gram of sodium hydroxide, the number of atoms that we can find, the number of chemical units that we can find here is 6.022 into 10 to the power 23, which is equal to 1 mole. So 1 mole of sodium hydroxide is equal to 40 gram, and the unit for monomers is gram per mole, so 40 gram per mole. Let's go to the next one and let's keep on calculating that. So MgCl, magnesium, is going to have 24 by the mass number, which I haven't written. Let me write it. Here we go. So if we are calculating the monomers of magnesium chloride, which is 24 plus Cl 35.5. So obviously this is going to be 24 plus 35.5 is 59.5 gram per mole. And carbon dioxide, carbon 12, oxygen 16, but we have 2 oxygens, so I have to add 1 more 16, or else I can multiply it by 2 simply. We can multiply it by 2. So if we have 3, we have to multiply it by 3. And this will be 44 gram per mole. So if we are taking 1 mole of carbon dioxide, the mass of the carbon dioxide, 1 mole of carbon dioxide will be 44 gram. And if we are given 88 gram, it simply tells us we have 2 moles of carbon dioxide. All right. Moving to the next slide. We have to find the relationship between mass, mole, and molar mass. So mole is N, we can write it down as N, and mass is M, molar mass is MR. So the relationship, the expression that can be given between mole mass and molar mass is mole divided by mole is equal to mass divided by molar mass, simply N equal M over MR. That is, if we have 2 moles of carbon dioxide, and the molar mass of carbon dioxide can be found, which is 12 plus 16 by 2. I'm using the mass numbers, so it will be 44 gram per mole. And here, if we have 44 gram per mole as our molar mass and 2 moles of carbon dioxide, simply the mass that we will have is 44 gram per mole. So solving M gives me 88 gram, and this is obviously correct because 1 mole of carbon dioxide is having 44 gram. So for sure, when it comes to 2 moles, it will be 88 gram. So we can also use this expression in order to find out the number of moles if the mass and molar mass are given. Okay, here we have some more calculations. So, how many moles are there in the following substances? And the first question is 200 gram of calcium carbonate. Calcium carbonate is CaCO3, and the mass numbers for calcium, it's 40, carbon 12, oxygen 16. So let's find out the molar mass first. 40 plus 12 plus 16 by 3. So this is 52, 16 times 3. So 48, obviously this is 100 gram per mole. So simply when we have 1 mole, the mass of the calcium carbonate is 100 grams. So if we are going to have 2 moles, this is going to be 200 grams. Or else, let's use the expression that we studied in the previous slide, that is mole equal mass over molar mass. And here, the question is to find the number of moles. So mass is given, that is 200 gram. Molar mass is found out, that is 100 gram per mole. So here, our number of moles becomes again 2 moles. So we do get the same answer when we are following both the methods. 2 moles, 2 moles. You can start working out the second question. Pause the video and work it out, and you can check the answer afterwards. So here I'm starting on working out the question. Carbon dioxide is simply CO2. So carbon 12, oxygen 16, 44 gram per mole will be the molar mass if I am finding it. So 44 gram per mole. And N equal M over MR, that is mole equal mass over molar mass. And the mass given over here is 66 gram, and the molar mass that we found out is 44 gram per mole. So simply dividing this gives me 66 by 44, and that is 1.5. Remember, the unit has to be mole since we are finding out the number of moles. Let's move ahead. This question is to find the mass. This question is to find the mass when the number of moles are given. So obviously, again, we have to find out the monomers. So calcium carbonate, we worked this out in the previous slide. Obviously, the monomers is 100 gram per mole. So N equal M over MR, that is number of moles equal mass over molar mass. Since we have to find the mass, I am rearranging this equation into this form, making the mass my subject. So N into MR, the number of moles, 3 moles, the molar mass, 100 gram per mole. So simply the mass will be 300 gram. Obviously, when we are finding the mass, yes, of course, the unit has to be gram. And also, yes, also from here, we are getting the gram as our unit, final unit. The next one, again, carbon dioxide. So 44 gram per mole is the monomers. Let's work it out. N equal M over MR. And the number of moles here. Yeah, it is given 2.5. It is given in the question. And mass is what we have to find out. Molar mass is 44 gram per mole. And solving this out will give us 44 into 2.5. And that is 110 gram. Hope that is clear. We are going to move to an advanced question. Let's read out the question first. Sulfuric acid and sodium hydroxide react together to make sodium sulfate and water. So this is sodium sulfate and this is water. Calculate the mass of sodium sulfate made when 20 gram of sodium hydroxide. 20 gram of sodium hydroxide reacts with excess sulfuric acid. So we are provided the sulfuric acid in excess, but the sodium hydroxide's amount is limited to be 20 gram. And yeah, now the question is to find out the mass of sodium sulfate that will be formed, and this is sodium sulfate. So first of all, let's work out the molar mass of each of these compounds. H2SO4. So for sulfur, it's given, all those amounts are given. So let's work it out directly. 1 into 2 plus 32 plus 16 into 4. And this is going to be equal to 32 plus 16 into 4 plus 2. That is 98 gram per mole. And Na2SO4. Na2SO4, if you are substituting 23 for sodium, 32 for sulfur, 16 for oxygen, what we are going to have is 16 times 4 plus 32, and it is 142 gram per mole. Okay, so when we have 98 gram of sulfuric acid, it represents 1 mole. So already the sulfuric acid over here has 1 mole, so it is equal to 98 gram. H2SO4 plus 2 NaOH, Na2SO4 plus 2 H2O. And we know that over here, the coefficients over here represents the number of moles. So since it has 1, we have 98 gram here. And let's find the molar mass of NaOH. So 23 plus 16 plus hydrogen, that is 1, and this is 40 gram per mole. Okay, so when we have 1 mole of sodium hydroxide, we have 40 gram, but we have 2 moles here, so that the mass over here will be 80 gram. And here it is 1, so obviously Na2SO4 142 gram. And the question is, calculate the mass of sodium sulfate when 20 gram of sodium hydroxide reacts. So when we have 80 gram reacting, we do get 142 gram. So if the reactant, that is sodium hydroxide's mass is 20 gram, which is 4 times lesser, what is the mass that we are going to get? Simply the ratio, it has to be 4 times lesser to 142, so that the answer will be 35.5 gram. I hope this gave you a clear idea. And now Here I have another question for you all. The answer for this question is in the description, so you all can work it out and find the answer in the description. All right, so yeah, that's it for today from this topic. Let's meet in another fresh concept, another video. Let's meet in another video with a fresh concept. Until then, take care. Bye.